possibly by this point you're feeling a little bit confused about what's going on here. So we said that if an irreversible process occurs in a closed system, then the entropy of the system always increases, it never decreases. And we were thinking about the free expansion as a gas expands out into a vacuum. And then we replaced this system with the reversible process where we had a cylinder of gas and we were taking weights off the top to allow the gas to expand slowly in a reversible way. And in that case, we knew that the heat flowed into the gas. We know that from our first law of thermodynamics, the change in internal energy is equal to Q plus W. And in this case, the temperature is remaining constant, so the change in internal energy is 0. And as the volume expands, the work done on the gas is negative, and so positive heat must flow into the gas. But this can be a bit confusing because surely if we can take masses off the gas and expand the gas, we could put masses back onto the gas and contract the gas. And if the gas is contracting, then work is being done on the gas. And if work is being done on the gas, it means that heat must be flowing out of the gas as long as it's at constant temperature. And if that happens, then we've got a negative change in entropy, which we just said we couldn't have. So what's going on here? Well, in that postulate, we were considering irreversible processes, and then we replaced it with a reversible process. So there's two problems with the system that we're considering. It's not an irreversible process. It's also not a closed system because the heat is flowing out of the gas as we add masses to it and into the reservoir. So if we were to consider a closed system, the closed system in this case would be that cylinder of gas with the weights on it and also the reservoir. And so the heat lost by the gas is the same as the heat gained by the reservoir. So because this is all happening at a constant temperature and the change in entropy is equal to, for processes at constant temperatures, the heat added divided by the temperature. In this case, the increase in entropy of the reservoir balances out the decrease in entropy of the gas. So the system as a whole has 0 entropy change. So this result's actually really generalizable. So we can actually come up with a better entropy postulate than what we had before, which will consider both reversible and irreversible processes. So our new entropy postulate, which covers everything, is that if a process occurs in a closed system, the entropy of the system increases for irreversible processes and remains constant for reversible processes. It never decreases. So this is a really powerful statement. The "it never decreases" is actually our second law of thermodynamics. So mathematically, we can write this as the change in entropy is greater than or equal to 0. And that is our second law of thermodynamics.